Good evening to all the lovely students. How are you? Very good evening. Welcome back to your own YouTube channel, Shri Chaitanya Gosala. I hope all of you are doing well. Very good evening. Had a good Sunday, and you're enjoying your class 11th bridge course. I hope you're finding it not too difficult from your class 10th. Few days it should look difficult because you have chosen a very good stream and a very logical stream, that is medical or non-medical, whichever you are preparing for. Okay. Yes, very good evening, Ganesh, Aradhya, Lasya, Kulusum, thumbnail designer, Bharti, Gantala, Gnansagar, Nandu. I see so many new students today. I have not seen some of the names in the last class. Saranya, Tali, Arifa, Sonali Yadav, Satya. Few of you are from last class. I can see some names like Lasya, Kumara. Yes. How many are new? How many of you are new to the class? Today you are attending the first class. Just say new. Ashwita, Malikarjun Rao, good evening. Health is great. Very good. Good evening. How many of you are new? Just write a new. Anivesh, Surya, Ranga. Good evening. Good evening. Sanjit. Very good evening. Okay. Pranati is new. Sonali Yadav is new. Very good evening. Very good evening. All right, everybody. All right, everybody. So before we start our today's session, all of you quickly like the video. Quickly like the video. And then we will start. Thank you, Glam Studio YouTube. I am glad that you are liking the explanation. So we will all like the video first, and then we are going to start our session today. Today we are going to do two things. Two new things we are going to do today. Two new things we are going to deal with today. First one is percentage compositions. So whenever there is any compound given to you, in a compound how much percentage of carbon is present, how much percentage of sodium is present, we are going to find that today. Percentage composition, different types of questions from there. And after that, we are going to talk about concentration terms. Okay. So two things we are going to do today. Two things we are going to do today. Today's topic. First topic we are going to do today is percentage composition. And second thing we are going to do today is going to be concentration terms. Concentration terms. Okay. So let us all quickly start with our notes. Take out your pens, notebooks, and let us continue. So, percentage composition means what? Percentage composition means nothing but in a particular compound, how much percent of a particular element is present. How much percent of particular element is present. Now, for example, if I say, let's say you are making a dosa batter. Okay, you are making a dosa batter. What you did while making a dosa batter is you added, let's say, 4 things into it. You added 100 grams of dal. Okay. In this, you added, let's say, 150 grams of rice. Okay. You add rice, you add dal. You added 5 grams of salt, and you added 5 grams of, what else do you add in the dosa batter? I don't know, but let's say 5 grams of peanuts you added. Okay, just I don't know how to make the dosa, but dosa batter. So these are things, let's say you added into the dosa batter. Percentage composition means percentage of each thing you have to find. So what will be the percentage dal in it? What will be the percentage rice in it? I can easily find. Percentage dal will be weight of dal added by total weight of dosa batter into 100. Correct? Into 100. So I can easily find. So it contains 100 gram of dal, whereas total dosa batter is how much? 100, 250, 260 gram. So 100 out of 260 multiplied by 100. This is the percentage of dal inside the dosa batter. Correct. Now instead of dosa batter, we'll be taking some compound. Let's say in chemistry, when I say in any chemical compound, when I want to talk about percentage composition, if you have a molecule whose formula looks something like this, C6H12, or let's take C6H7O. Okay, this is the molecular compound that they have given you, C6H7O. And they ask you what is the percentage of carbon in this, percentage of hydrogen in this, percentage of oxygen in this. Let's say such a question comes. So you do nothing but you take 1 mole of this compound, check how many grams of carbon is there, okay, divided by total mass, molar mass, into 100. Okay, so what we are going to do here, let's say I want to find percentage of carbon. So you can see what formula you will be using from now on. Percentage of carbon, if I want to find, each mole of this contains 6 carbon atoms. Each carbon has molar mass of 12 gram. So there is 6 times molar weight of carbon. 6 times molar weight of carbon divided by molar mass of compound into 100. Simple. When I take 1 mole of the compound, it contains how much carbon? It contains 6 times 12, means 72 gram carbon. By total molar mass of compound is how much? It is 6 carbons, means 6 times 12, plus 7 hydrogens, means 7 times 1 gram, plus 1 oxygen, means 1 times 16 gram. This is the overall molar mass into 100. And then you have to do the calculation. Okay, calculation part will be done later, but I am just telling you a simple basic question that this is how you can find the percentage of carbon. So what is the percentage formula? It is simple. Remember the percentage formula. Number of atoms of a particular element into molar mass of the element. Number of atoms of a particular element into molar mass of the element divided by molar mass of the compound into 100. So quickly write down the formula, then we are going to start our questions. Okay, write down. Percentage element is equal to number of atoms in one molecule. Number of atoms in one molecule, number of atoms of the element. Number of atoms of the element, let me call element X. Element is X. So percentage of X is number of atoms of X in one molecule into divided by into molar mass of X divided by molar mass of compound, molar mass of compound into 100. That is the percentage formula. Okay, that is the percentage formula. It is very simple. You don't have to learn the formula. You don't have to learn any formula. You can keep the chat off. Okay, you don't have to learn the formula. It is just a simple basic mathematics that we are doing. So when you take 1 mole of a compound, its total mass will be molar mass of compound. Inside that, how much of an element is present will be nothing but number of atoms of that element multiplied by molar mass of the element. So if I want to find the percentage of X, this is how I can find. Okay. For example, just quickly I'll show you some example. Example, if the formula of the molecule, is something like CH4, in this percentage of carbon will be what? Percentage of carbon will be, first see how many carbon atoms are there. Sir, only one is there. So number of atom is 1. What is the molar mass of carbon? Sir, 12 gram. So I'll put 12 here. So 12 gram carbon is there inside it. Total mass is 16 gram for CH4. 12 plus 4, 16 gram into 100. So which is nothing but 12 by 6 into 100. On the table of 4 I am cutting 3 by 4 into 100, which is 75%. 75%. And percentage of hydrogen will be how much? Now, as you know, sum of percentage is always 100%. So in this case, if carbon is 75%, if I make a pie chart, if carbon is 75%, then hydrogen has to be 25%. Because sum of percentages is always 100. I can say like that. Otherwise, I will find it. 4 hydrogen atoms, each hydrogen weigh 1 gram. Each mole of hydrogen weigh 1 gram. Total compound weighs 16 gram into 100. 4 by 16 into 100, 25%. Okay, first example. One more example, just one more example, and then we are going to solve our questions. Let's say they say find the percentage of oxygen, percentage by mass of oxygen in NaOH. In NaOH, they say what percent by mass oxygen is present. What percent by mass oxygen is present. So you will say, sir, percentage oxygen equal to, there is one oxygen atom. So 1 times 16 gram, there is one oxygen atom which weighs 16 gram. So 1 times 16 gram by total molar mass of NaOH. Sodium is 23 gram. Sodium is 23 gram. Plus oxygen is 16 gram. Plus hydrogen is 1 gram into 100. Okay. Which is 16 by 40 into 100. 16 by 40 into 100. Which is exactly how much? 40%. On the table of 4, I am cutting it at 4 times. Okay. 0, 0. This goes 4 times. 40%. Simple. Very simple. So just learn the formula. Quickly write down these 2 examples. And now I am going to give you few questions. So it's a very simple type of question. Sometimes question become little difficult from percentage composition. I'll show you how. Okay, I will be showing you how the questions can be asked in a difficult manner from this simple topic. These are 2 very simple questions I told you. That how much percent carbon is there in CH4? 75%. How much percent hydrogen is there? 25%. Same way this question also I have told you. So just remember, how many atoms do you see into molar mass of that element X divided by total molar mass of compound into 100. Shall we start with the questions, everybody? Shall we start with the questions, everybody? Yes. Okay. So all of you can start with the first one. Quickly answer. This question should take 1 minute only. Less than 1 minute. What is the answer? Calculate the percentage composition of carbon in ethane. Percentage composition of carbon in ethane. Quickly. Sheikh Reshma, watch the video once again. Yes, Surya, you can ask your doubt. Except for saying once again, I will take doubts. Okay. Once again is not a doubt. Once again, that is your mistake that you are not listening initially. 80%, good. Doubts I can take. Once again is not a doubt. Okay. You can't just go to a movie and because you came 10 minutes late, after 20 minutes you can't say, sir, start the movie again. Okay, movie will not be started again. But yes, if you have a doubt, sir, what happened in the first 2 scenes, I can tell. But movie can't be repeated. Yes, 80% is correct. Very good. Simple. Ethane is C2H6 gas. This is ethane. So percentage of carbon will be 2 carbon atoms, each carbon 12 gram by molar mass of ethane, which is 24 gram carbon plus 6 gram hydrogen into 100. So it is 24 gram carbon in total 30 gram of ethane into 100, which is 80%. Good. 80%. Yes. Okay. Now let's go one step ahead. Yes, Surya, your answer is yes. Let's go one step ahead. Let us make the question little difficult. Okay. Are we all ready for the next question? Yes or no? Are we all ready for a little difficult question? Are we all ready for a little difficult question? Let's do that then. Question is this. An enzyme contains 20% sulfur. An enzyme contains 20% sulfur. What could be the possible molecular mass of enzyme? There is an enzyme which contains 20% sulfur. What could be the mass of enzyme? I am not asking what is the mass of enzyme. What could be the mass of enzyme? Think. What could be the mass of enzyme? Someone says option 2, someone says option 4. Option 1. Okay, that's correct. I think Janvi is your name. Janvi says 640. Okay. Nandu says 350. Kishore says third option 640. Good. Good. How should we tackle such a question? What is the enzyme in question? We don't know, Sushant. We don't know what is the enzyme. We have no idea what is the formula of enzyme. Enzymes are organic molecules only, but we don't know what is the formula of enzyme. We have no idea. All right, all of you see here. All of you see here. Let's say this is one molecule of enzyme. This is one molecule of enzyme. In one molecule of enzyme, how many sulfurs are there? I don't know. How many sulfurs are there? Maybe 1 sulfur, maybe 2 sulfur, maybe 3 sulfur. I don't know how many sulfurs. So let's keep number of sulfur atoms to be X. Let's say one molecule of enzyme has X sulfur atoms. X sulfur atoms. So formula of enzyme may be something like C12H22 S X times. So sulfurs are X. I don't know what other things are present, but sulfurs are X. So direct formula, percentage of sulfur will be number of atoms of sulfur X into molar mass of sulfur which is 32 gram by molar mass of enzyme, full molar mass of enzyme into 100. Into 100. This is the formula. If I say that enzyme contain X atoms of sulfur, then percentage sulfur will be what? X atoms of sulfur into 32 gram by molar mass of enzyme into 100. This is what they are asking. Molar mass of enzyme is what they are asking. This is unknown. What do I know? I know percentage of sulfur, 20% equal to X times molar mass of sulfur, which is 32 gram into 100 by molar mass of enzyme. That's all. So our answer comes out to be 20. This goes 5 times. So our answer comes out to be molar mass of enzyme is 5 into 32 is 160. 160 x grams. 160 x grams. What is the x? Now obviously in a particular Sudhir? हाँ नहीं वो स्ट्रीम हो रहा है. Okay. So X now, what is the X? X is the number of sulfur atoms, and obviously in a particular molecule, number of sulfur atoms cannot be fractional. It has to be either 1 or 2 or 3 or 4 or 5 like that. So answer will be a multiple of 160. Answer will be multiple of 160. So molar mass of enzyme may be 160 into 1 gram means 160 gram. It may be 320 gram. It may be 480 gram. It may be 640 gram. It may be 800 gram. It may be 960 gram. Correct. So answer has to be a multiple of 160. Answer must be a multiple of 160. So answer may be 160. But the question was, what is the possible? What could be the possible molar mass of enzyme? So it may be 160, it may be 320, it may be 640. So 640 is the answer because others are not multiple of 160. Is it clear, everybody? Sir, how did you get 32? 32 is the molar mass of sulfur, beta. 32 is the molar mass of sulfur. Is it clear to everybody? Yes or no? Anivesh, 32 is the molar mass of sulfur. Third option is correct. Yes. Yes. Okay. Good. Let's go for the next question now. Next question I want you to do. In the same way you have to do the next question. In the same way you have to do the next question. Not wrong way, Mandapalli, you might have done it in a correct way only, just that you not by using formula, you might have done it by any other method, but still if you're getting the correct answer. I don't know what is the enzyme. This is just a question made by me. There is no such enzyme. I am just making the question and giving you. Okay. I hope it is clear to everybody. Next one. Next one. Now I'll give you one daily life question. Okay. You tell me, I am saying that a class, let's take class 10th. A class, let is class 10th A, section A, contain 25% girls. What could be, or not, don't take 25%, let's take a class 10th contains 12.5% girls. What could be minimum number of students in class? What could be minimum number of students in the class? Okay, what could be the minimum number of students in the class? Think about it. Okay, just a normal question I am asking. You have a class. In the class, there are 12.5% girls. 12.5% girls are there. Then how much should be minimum number of students in the class? Options are number 1, 80 students. Number 2, 100 students. Number 3, 16 students. Number D, 8 students. And E, 4 students. Think about it. Sushant, when you use the word we, I am thinking that all of you are not understanding. Okay. So, Sushant, are you talking about yourself? You have to listen to the class from the beginning. You have to listen to the previous classes as well. 8 is the correct answer, everybody. 8 is the correct answer. 8 is the correct answer, not 4. 8 is the correct answer. Now, why do I say 8 is the correct answer? You think about it, everybody. You think about it. Why am I saying 8 is the correct answer? See here, everybody. This is the class. In a class, how many girls could be there? Let's take X number of girls. Let's take X number of girls, and X has to be 1, 2, 3, 4, 5 only. You cannot have half a girl. You cannot have 1.5 girls. You cannot have 2.5 girls. X is the number of girls. So number of girls are X in the class. X number of girls in the class. X number of girls in the class. So we can say percentage girls equal to X, which is number of girls, by total students into 100. Percentage of girls is 12.5 equal to X number of girls by total students into 100. From here we get total students is equal to 100x by 12.5. This exactly goes 8 times, everybody. Answer is 8x. Answer is 8x. So total students are 8x. Total students are 8x. Now what could be x? X is number of girls. X is number of girls. For a minimum, x has to be 1. No. How can you have less than 1 girl? So x minimum must be 1. If x is 1, then students are 8. This is the minimum number of students then. You can't have less than 8 students. When there are 8 students, 7 will be boys, 1 will be girl. If x is 2, if there are 2 girls, then total students become 16. Then this is not minimum. So possible number of students are 8, 16, 24, 32, but minimum is 8. So answer is 8. Answer is 8. Okay, so this is the logic only. Correct only, no? In the same way, you have to do next question. In the same exact way, you have to do the next question. If you are liking the class, please do not talk among yourselves in the class. Now, do you do the same thing in your normal class as well? When you all come for the offline classes, you will not be able to do this. You will not be able to do this. Okay? Yes, these are logical thinking questions. Now, logically you are able to think. Do this question then. There is a polymer which contain 1.6% bromine. 1.6% bromine what is the minimum molar mass of bromine? Okay, 1 minute. आया तो नहीं 9259 आउटसाइड बाहर उस पर रख दो, आपको दिख रहा होगा ना। हाँ ओके ओके, हाँ शुरू है। Yes, what is the answer, everybody? Many are saying option 2, many are saying option 1. Should it be 1 or 2? See carefully now. This is where you get stuck. This is like a NEET level question only. NEET asks exactly the same way. NEET based question. Exact same question has been asked in NEET. Number might be coming 5,000. Should I answer 5,000 gram or 5,000 AMU is the thing. Now I am asking molar mass. Molar mass. Molar mass can never be in AMU. Can never be in AMU. Beta, AMU means mass of one molecule. It has to be molecular mass. So if the question was what is the minimum molecular mass, answer must be in AMU. Answer must be in AMU. Answer has to be in gram if they are asking molar mass. Very first day I told you, second day I told you what is the difference between molecular and molar. All of you got trapped in my jal. Jal was molar. Molar means gram. Molecular means AMU. You don't have to determine X, beta. X will be 1 here. Minimum I am asking. No, minimum. So keep minimum number of atoms. In one particular molecule, how many minimum atoms of bromine you can keep? 1 atom? No. How can you keep less than 1 atom? How can you keep less than 1 atom of bromine? So consider that this is your molecule. This molecule contains exactly 1 bromine atom. Then automatically, when girls were becoming minimum, automatically students also became minimum. When I took 1 girl, students were 8. When I took 2 girls, student became 16. So whenever they ask you minimum number of, whenever they ask you minimum molecular mass or minimum molar mass, just take 1 atom of the given type, single atom. I hope you got stuck. Next time don't get stuck. Question is molar mass. So answer can never be AMU. This is to not possible. This is to not possible. If the question was molecular mass, then AMU would be the correct answer. So let us do now. This is that polymer that I am talking about. In a polymer, there is 1 atom of bromine. So the molar mass will become minimum. So the formula will be percentage bromine equal to atoms of bromine into 80, which is the molar mass of bromine. Molecular mass is 80 AMU, molar mass will be 80 gram. Divide by molar mass of polymer into 100. Okay. If I take it as X atom of bromine, if you take it as X, you will get the possible mass. But I am asking minimum. Minimum means 1 atom of bromine only you take. So percentage is 1.6%. 1 atom of bromine, 80 gram by molar mass of polymer in 200. So molar mass of polymer from here comes out to be 5,000 gram. Molar means 5,000 gram. Okay. If you take it as x, you will get 5,000 x. If you took x value as 1, 5,000 gram, x value as 2, 10,000 gram, 15,000 gram. These are the possibilities. Minimum means you have to take the minimum answer, means 5,000. So answer is 5,000 gram. This is the answer. Option 1 is the answer. This is the molar mass. This is the molecular mass. Less than 5,000 is not possible only because whenever bromine atom is 1, answer is coming 5,000. Less than 1 bromine atom is not possible. So less than 5,000 answer is also not possible. Okay, so this is about. And one more we'll do now. Let's do this one, everybody. This is the last we'll do today. Pushparani, you take atoms as x. Previous question I told you, na, when I took the number of girls as x, students came out 8x. When you want minimum students, you take minimum girls. Minimum girls in a class can be how many? Can you have half a girl? Can you have 0.8 girls? No, you have to take one girl, no. So whenever question comes from minimum mass, you must take one atom of bromine. You must take one girl in the class. Which atom is given? You take always one atom. Okay, never take 2, 3, 4. Is it clear to everyone that why we are taking one bromine atom? Is this clear to everyone or not? This is simple basic logic I have told you. When you want minimum molecular mass, you take minimum atoms. Is it clear? Yes. Tell me about this. I want all of you to watch the video once again. So to those who are saying it is not clear, okay, please watch the video once again. Calculate number of iron atoms in a hemoglobin molecule. In a hemoglobin molecule, atoms cannot be 4 Na. Okay, obviously Na, Avogadro cannot come here. So option will be either 2, 3, 4 or how many are there that you have to find. So if this is hemoglobin, there are some iron atoms. I don't know how many. How many are there? I don't know. Let's take X atoms of iron. Let's take X atoms of iron in a hemoglobin. Each iron weighs 56 gram. You should know that. Okay, you should know that molar mass of iron is 56 gram per mole. Or 56 AMU is the atomic mass of iron. Anything is fine. So, what will be the percentage of iron? Percentage of iron will be number of atoms of iron, which is X I am taking here, into molar mass of each iron 56 gram by molar mass of hemoglobin, which is 67800 gram, into 100. That is the formula, simple formula. Percentage of iron is 0.33%. 0.33% equal to X times 56 times 100 by 67800. Okay, 0.33 I can write it as 1 by 3, which is 33 by 100 I can write, 33 by 100, or 1 by 3 I am writing it. Okay, 33 by 100 is 1 by 3 only, no? So 1 by 3 equal to X into 56 into 100 by 67800. 0000 cancel out. So X comes out to be 1 by 3 into this 678 goes up and 56 comes down. 678 goes up, 56 comes down. On the table of 3, I am cutting it 2, 2 and 6, 226. which is exactly 4 times of 56, almost 4 times. So almost 4. So answer is 4 atoms. Answer is 4 atoms. Okay. If the question was 3.999 means 4 atoms only, so 4 times it is going. So if the question was how many number of iron atoms are present in a 1 mole of hemoglobin, 1 mole of hemoglobin, then answer will be 4Na. Okay, if the question was number of iron atoms in 1 molecule of hemoglobin, answer is 4. 1 molecule is very, very small. In a molecule, 4 atoms of iron. Okay. But if the question was number of iron atoms in 1 mole of hemoglobin, 1 mole means Avogadro hemoglobins, then 4Na will be the answer. Number of iron atoms in 1 mole of hemoglobin, I am writing it as HB, hemoglobin. 1 mole, then there will be 4 Avogadro atoms. So this type of trap they will keep, 4Na, 4. If the question was mole, then 4Na will be the answer. When the question is molecule, 4 is the answer. Okay, so keep this in mind. So let's go for one simplest question for this class. Very simple question. Do this one also. What is the percentage composition of sodium in sodium thiosulfate? Sodium thiosulfate. All of you get this one. Get this one. What is sodium in sodium thiosulfate? How much percent sodium? Okay, some are saying 42%, some are saying 29%. 29%, okay. All right guys, this is the last question we are doing here for this class. Then we'll start with the concentration terms in the next particular class. Sodium thiosulfate, this is the formula. Those who don't know the formula, by the end of class 11th you will be knowing all the formulas, because one chapter will come redox reactions, in that all particular formulas will study, and all the names of radicals and metal cations and all those names also I'll be telling you in one particular class, so that you know all the names and everything. Okay, we'll keep one class for that as well. So we'll just, right now I've given you the formula. Sodium molar mass is 23 gram per mole. Sulfur, it is 32 gram per mole, and oxygen, it is 16 gram per mole. These are their molar masses, all of you should remember. So we'll say percentage of sodium will be 2 times molar mass of sodium, which is 23. That means each thiosulfate mole contains 46 gram sodium, by total molar mass, which is 2 times 23 for sodium, plus 2 times 32 for sulfur, plus 3 times 16 for oxygen, into 100. This is 46 upon 46 plus 64 plus 48 into 100. Okay, which is 46 upon, this total become 110. Okay, this is 110 110 plus 48, 158 into 100. Okay, I hope all of you will calculate this yourself now afterwards, and you are going to get what? Are we getting 30%? Yes or no? Are we getting 30%? 30% is correct. So 29% around you will be getting. When you do the calculation part yourself, 29% around you will be getting. Okay. I hope it is clear to everyone. Please like the video before you log out. Okay. And wait for your next class, which will be at 5 o'clock. So that is all. Bye bye everyone. Take care. Bye bye. See you all. Is it clear to everyone? Just write a clear if it is clear to all of you. And then in the next class, I'll meet you all again. Just write a clear. I'll wait for your final chat. Bye. Have a great day. Have a good day. Bye bye. Okay, Tali, good. Yes. Okay. Bye bye. Thank you.